Have you ever wondered what keeps the universe in constant flux? It's the fascinating world of motion. This isn't just about moving cars or flying birds. From the tiniest particles to the grand celestial bodies, everything is in motion. It's the dance of atoms, the orbit of planets, the spin of galaxies. This relentless change in position, this movement, is what we call motion. And it's this fundamental concept of motion that sets the stage for the intriguing world of physics. What pushes the world around us? The answer lies in the concept of force. Force, an invisible hand that shapes the universe, can be as subtle as gravity pulling an apple towards the earth, or as dramatic as a rocket blasting off into space. This push or pull that we call force is fundamental to understanding the physical world around us. Now enter Sir Isaac Newton, a 17th century physicist, who revolutionized our understanding of force with his 3 laws of motion. The first law, also known as the law of inertia, states that an object will remain at rest or in uniform motion unless acted upon by an external force. The second law explains how force, mass, and acceleration are related, while the third law states that for every action, there's an equal and opposite reaction. These laws, simple yet profound, govern the motion of every object in the universe. Force, the push or pull on an object, and Newton's laws govern the motion of every object in the universe. What fuels the universe? It's the enigma we call energy. Energy, in its simplest form, is the capacity to perform work. It comes in various types, like kinetic energy, which is energy in motion, and potential energy, the stored energy of an object. Then there's thermal energy, the energy of heat, and radiant energy, which travels in waves like light from the sun. These energies power everything, from the beating of our hearts to the burning of stars. Energy, the ability to do work, is the driving force that powers the universe. What keeps us grounded? The unseen yet ever-present force of gravity. This force, first comprehensively studied by Sir Isaac Newton, is a vital player in the cosmic drama. It's what keeps planets in orbit around the sun and stars clustered in galaxies. Imagine you're at the top of a tall building with a tennis ball in your hand. If you drop the ball, it plummets downwards. That's gravity in action. Now consider the term free fall. It's not about falling freely or without restrictions. Instead, it's about falling under the sole influence of gravity, without any other forces acting upon it. An object in freefall experiences no air resistance, and it's gravity that accelerates its descent. Interestingly, gravity isn't just confined to our planet, it's a universal force, acting between all objects, everywhere, all the time. It's the invisible architect shaping the cosmos and determining the structure of the universe. Gravity, the force that attracts 2 bodies towards each other, is the invisible glue that holds the universe together. What sparks life into our tech gadgets? The hidden power of charge and electrostatics. Let's dive into this electrifying world. Everything that we know, every piece of matter, is made up of atoms, and at the core of these atoms are electric charges. When these charges are stationary, we're in the realm of electrostatics. The magic begins when an object gains or loses electrons, creating an imbalance of charge. This imbalance is what we call static electricity. Now picture this static electricity on a grand scale. We're talking thunderstorms. The lightning we see is a spectacular display of electrostatic discharge. On the flip side, this same principle powers the very device you're using to watch this video. Your smartphone, your laptop, they all rely on the movement of charges or current. Charge, the property of matter that causes it to experience a force in an electromagnetic field, and electrostatics, the study of stationary electric charges, power the world around us, from lightning to smartphones. What paints the world in vibrant colors? The magic of light. Light, a form of energy visible to the human eye, follows fascinating principles in its journey. The first stop on this journey is reflection. When light encounters a surface, it bounces back, much like a ball hitting a wall. This bouncing back is what we call reflection. Now, let's dive into refraction. Imagine light as a car driving from a highway onto a dirt road. The change in speed as it hits the dirt road is similar to what happens to light when it passes from one medium to another. It bends. This bending of light is refraction. Finally, we come to dispersion. Ever wondered what causes a rainbow? It's the magic of dispersion, the splitting of white light into its component colors when it passes through a prism. Reflection, refraction, and dispersion, the phenomena that govern the behavior of light, paint the world in vibrant colors and bring clarity to our vision.